Hey gang, we're gonna dive into a real life example of a function in which we can draw some information from its graph. All right, so let's share it with you, my PowerPoint slide, and we're doing an average cost function. All right, an average cost function. So let's say the average cost, and we're going to denote that. Do you know what denote means? Denote means the symbols that we're using to represent something. So we're using C with the bar over it to represent the average cost function for manufacturing X drones per day. So some company has done statistical analysis and come up with a function that approximates pretty closely the average cost for making a certain number of drones a day, depending on the cost factors, okay? And so they've come up with C of X. So the cost for X drones, making X drones a day, would be 0.7 X squared minus 45X plus 1,320.2 plus 10,000 divided by X. And so we could determine the average cost by substituting in 10, 20, 30, and kind of getting an idea of whether the cost goes up or does it go down, depending on the different things that play into it. All right, so these first A, B, and C should be fairly straightforward. You can do them on your calculator. Letter A would be C of 10. B would be C of 20, and C would be C of 30, okay? Now, let me just show you real quick on my calculator. Well, actually, we don't need to do that. Let me just show you right here in the PowerPoint. C of 10 would be 0.7 times 10 squared minus 45 times 10 plus 1320.2 plus 10,000 divided by 10, and you could put that straight all the way in on your graphing calculator. I will show you this real quick. Okay, let me just show you real quick how you put that in all in one. So quit out of that. Oops, I can quit. All right, so you want 0.7 times 10 squared. This is putting in 10 minus 45 times 10 plus 1,320.2 and then plus 10,000 divided by 10. And this one, it'll do the order of operations right here. And what we get is that it costs $1,940.20. Now you can do the same thing again for 20 drones. And I think we also did for, get how many drones did we do? All right, so we did for 20 and 30. And so we found for 20, the cost goes down. And then for 30, it goes down even more per drone. All right. So, and that makes sense. The more drones you make, the more you can use your resources that you've already set up. But we would like to also graph this function. Okay. Now, let me go back to the main function here. And I'm going to give you a moment to write it down. Have you written this down? Would you pause me real quick? Write down this function. C of X equals 0.7 X squared minus 45X plus 1320.2 plus 10,000 divided by X. Okay. All right, you've got that written down. And now I'm going to go over here to my calculator and I'm going to put it in mine under the Y equals menu. So it was 0.7 X squared minus 45X plus 1,320.2 plus 10,000 divided by X. Now, what happens if I do like we've done before and I do zoom number 6 standard? I'm not getting much help from this graph. All right. So let's go back here to our PowerPoint screen. And I want to show you how they drew the window. All right, notice here that their X values go from 0 to 60 and their Y values go from 0 to 1,500. Let me show you how to put that in on your calculator. So they did their X values from 0 to 60. Wait, what am I sharing here? Am I sharing this one right here? Yes, I am. Okay, but I can't see what I'm sharing. All right, there we go. All right, so on my window, I want my minimum X value to be 0 and my maximum X value to be 60. So this is 0 to 60 on the X. And then I'm going to go down. My minimum Y value was 0, and we went all the way up to 1500 on the Y. Now, if I hit graph, my graph will match the one that we saw in the book. And so now I see that the cost is going to go down, 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 down until you get to this point right here. And then the cost per drone is going to go back up. What could make the cost per drone go back up? Maybe once you've made this many drones, between 0 and 60, I'm thinking we're around 40 or something, 45. Maybe after 45 drones, you have to hire more people or build a second machine. Maybe you need to rent a third building. You know, something about this spot makes the more drones you make, instead of the cost going down per drone, now it suddenly starts to go up. And what we want to do is figure out what's this best spot right here. When's the cost the least? And we could do that on the TI-83 using the calc feature, which is above trace. To get to any of the functions in yellow, you hit the yellow button, the second calc. We want to calc the minimum value. Where's this minimum point here? What is this lowest point? And it'll say, well, what's the left bound? I'm looking for this lowest point here. So I want to first tell it, I want it a little bit to the left of that. That'll be my left bound, and press enter. And then it'll say, well, what's the right bound? So I'm going to arrow over a little bit until I'm on the right side of that minimum point I'm looking at. All right, now I'm on the other side of it. I'll press enter. And then it's going to say, do you want to guess? And I'm like, yeah, please do. And so then I'm going to press enter, and it'll calculate it for me. The minimum is going to be when we make 37 drones. All right, if we make 37 drones, we're going to have the minimum cost, and the minimum cost per drone looks like that's about $883. Okay, so if you are working with a business, then you're going to kind of have a good guideline of where you should aim to get the most bang for your buck, right? Minimize costs, maximize revenue. All right, with all that said, that's a real life example there. And our keyword from this one is minimum, because we were looking for the minimum cost. You would want to maximize revenue, maximize profit, but we always like to minimize the cost for any of you going into business applications. All right, we'll see you later.